Okay, so here's our chance to go through the paper 6 investigation. We'll start working through it and see where the marks are awarded and what we need to be watching for. So first page here, we're obviously doing an investigation, looks at the number of spheres and rods that you need to make models of molecules. As I went through this as a whole, if I'm going to summarize, I would say the thing to watch for is just making sure you're labeling things with the correct letters. That's the point where it's easy to get confused and a little bit unsure of yourself. So that's what we're going to try and do throughout, and I'll guide you through that process. Okay, so leading us in quite nicely, draw the next two molecules in the sequence, having looked at the ones above, obviously. We're looking for, keep it in black. 1, 2, 3, 4. Connected with 3 lines. Might make them a bit bigger just so it's really obvious. Don't want to miss out on any marks. And the next one is with 1, 2, 3, 4, and 5. Connected like so. Okay, let's just have a look at the number of spheres we've got. On molecule number 3 was with 3 spheres. That's quite consistent. So we're looking at the next one, the 4th one, and we're seeing we've got 1, 2, 3, 4. Okay, that works. Exactly what we're expecting to see. So this just follows the pattern. 4 here, 5, and then it would be 6. Next one, again the number of rods follows 1, 2, then 3, 4, and 5. Okay, some nice linear sequences going on here. Write down a formula for S in terms of M. So S is what we want. So S, what does S equal in terms of M? How does S link to M? How does this S link to this M? How does this number link to this number? Similarly, all of them, how does this number here link to this number? Well, they're equal. So S just equals M. And that's the page done. Now there is 3 marks available on this. First one here for this diagram correctly. Second one for getting this table written out in full with everything correct. And a third one here for getting S equals M. Okay, let's move on. Turn the page. And we got question number 2. These diagrams show a sequence of molecules of height 2. Complete this table in height of 2. Okay, let's just look at what we need to spot here. So we're looking at the number of spheres, and you can see there were 2 here for the first one, for the second one, 1, 2, 3, 4. So we've got 2, 4, 6. We can see the pattern. In fact, we can count them further. 4th, 1, 2, 3, 4, 5, 6, 7, 8. And that follows the pattern that we're seeing. So there's 8 here, and the pattern is that it's going up in 2. So that's quite nice and straightforward for us to fill out. Next one. If we look at the pattern that's building up, 1, 4, 7, it's going up in 3s. Let's just check on this next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, that's what we expect. So this is 10. If it's going up in 3s, it's got to then be 13 and 16. Find, in terms of M, a formula for S. So again, what we're looking for is how does S link to M? Well, from 2 to 1, from 4 to 2, 6 to 3. What do we do to M to get to S? Well, S has to equal 2 lots of M, doesn't it? There's quite an obvious link there. So that's what we're going to write in. S equals 2M. How then does R, again, link to M, the molecule number? Well, these first 2 are equal. This one's, it's a slightly different thing here. But we do know how sequences work. And so we've done that in class. Let's have a look. And how much is it going up by each time? Is there a common difference? Is it a linear sequence? Well, yeah, we're adding 3 each time. That's what we said earlier. So it's going to be 3 lots of M. Or it's going to be like the 3 times table. That's how we kind of put it together. But it's not exactly the 3 times table. It starts on 1. Instead of on 3. Obviously my 3 times table starts on 3, this one starts on 1. So my sequence is 2 less 3m minus 2. And marks for this page, again, we're looking at 3 marks. What have we got? First one for the entirety of the table, second one for the 2m, and the third one for 3m minus 2. Okay, great, feels like we're on a roll. Let's keep moving. Okay, diagrams again, counting spheres, counting rods, and I'll not count them for you this time, but let's have a look at what we've got. So 3, 6, 9, 12, 15, 18, 2, 7, 12, all this is going up in 5s, 17, 22, 27. Okay, so we're looking for a formula again for S in terms of M. So M obviously is just effectively the number in the sequence, but it links back to this one. So how does this number link to this? Well, this is going up in 3s, and it is the 3 times table, so it's just 3m. This is equal to 3 lots of m. Now on this one, what have we got? Well, it's going up in 5s, but it's not exactly the 5 times table, so it's going to have to be 5m. Now let's think, how do I get from 5 down to 2? Take away 3. So for this one, 5m minus 3. And there we have it. Predictably, 3 marks. 1, 1, and 1. Okay, right, now things are starting to look a little bit more complex. We're adding another layer of what's going on. So let's just look at the advice it gives us. It says to use my answers in questions 1c, 2b, and 3b to help complete the table for molecules of height h. Okay, so height h is 1. Now, let's go back. If height h was 1, that's back here, right at the very start. And, okay, so that's the first page I need to look at in a second, but what's it actually asking for? S in terms of m, first of all. Oh, that's what we worked out already. And the number of rods are in terms of m. Well, that's given to us. Oh, this is just copying out the information, all the work that we've already done. So the first one, S equaled m for a height of 1. So if S equals m, let's just put it in. So S equaled to m. Oh, I don't want that in red. Let's change it, S equal to m. For the second one, what did we have? We had here 2m, and I can look on the way back. The next one's going to be here 3m. So we found for this one that we've got 2m, 3m. Oh look, 4m fits nicely with the 5m. It must be 6m next. Okay, number of rods. Now let's fill those in. So what did we find? Well, we didn't get the first one, but that's given to us. Then I've got a 3m minus 2 and a 5m minus 3. So what did I say? I just said 3m minus 2 and 5m minus 3. Okay, what's happening here? Well, we've gone from 1m to 3m to 5m. There's a 9 coming, fitting in between. It's got to be a 7m. They're all subtracting something. Let's put in the 11 as well. They're all got to be subtracting something. Let's look at what it's subtracting. Well, it's gone from here, minus 1, minus 2, minus 3, 4, minus 5, and minus 6. So let's fill it all in. It's all fitting quite nicely. Minus 4, minus 5, and minus 6. Okay, now let's try and work out exactly what it's asking us for in this situation. Find, in terms of m and h, a formula for s. Okay, so s is here. So this is what we're interested in. So in terms of m and h, how does it work? Now h is just this value here, so it's 1, then 2, then 3. So for the first one, I've got 1m. So h was 1, I've got 1m. For the second one, I've got h is 2, and it comes 2m. Okay, there's something going on here. For h is 3, I've got 3m. So whatever h is here, whatever it might be, that is what I multiply by m by in order to get s. And that's what that column represents. So s just equals h multiplied by m. Whatever h was, I multiply by m, and that tells me what this expression is in all of these points in the column here. Okay, something similar again. Let's look at this. The number in terms of rods in terms of m. So we need r in terms of h's and m's. How does it link? Okay. Now, what I'm going to do is I'm going to look at this formula and I'm going to see how I can describe these numbers essentially in terms of h. Now, I know that this formula looks like this. It looks like I've got something, then an m, and then I've got a takeaway something else. And I'm going to see if I can describe those things in terms of h's. H obviously is just this number here. So how does this number link to this number? 3 to 5, 4 to 7. Well, what have I got here? And it's spotting this pattern. What's going on? Well, my sequence here is going up in 2s, isn't it? So 1, 3, 5, 7, 9, and then 11. So it could be 2 lots of h. And if I think about 2h, what do I need to adjust it to? We're going to have to subtract 1. So this first number here, and this is just my workings, is that going to work to be 2h minus 1? Lots of m. So that's all I'm doing is I'm just describing this first number here. 2 lots of h, take away 1. Yeah, that works. And then what do I take away? Well, it's 6 here. And it's 6 here, it's 5 here, and it's 5 here. It is just whatever the value of h was. So I can just take off an h. And it looks to me, when I look through a couple of examples, I'm quite happy with that as an answer. So I'm going to put it in. So it's going to be 2h minus 1, lots of m, take away an h. Okay, like I said, we really are on a roll now. A couple of questions to go. Oh, didn't go through the marks here. So for this one, there's 2 for the table, 1 for each column. There's 1 here for this formula, and another 1 for this formula here. Okay, question C. Use your answer to part BI to find a formula for m in terms of s and h. Okay. So let's just look at what we got for B part I. You can look across the page, but we got s equals hm. That was my answer. So I'm just going to write that out here so I can refer to it. So I'm taking on the advice, s equals hm. So what's it asking for? Find a formula for m in terms of s and h. These are just the letters that we've got. We don't need to do any substitution. We just need to rearrange it. So it's a formula now for m. So if I look at this and I divide both sides by h, what am I left with? It's s over h equals m, or m equals s over h. There we are. Part D then asks us to find a formula for r in terms of s and h. Okay, so let's have a look back at what we've got. R, s and h is what we're looking for. R is this one down here, but we want it in terms of s and h. So let's go back. I'll copy it out again. So my formula was... So my answer on the previous one was r equals, and again, you can just refer to this, you can look at it across the page, just because I can't, I'd save me going back and forth. 2h minus 1, m minus h. Now it's asking me for a formula for r, which is actually what we've got. We do already have a formula for r, because r is the subject. Trouble is, ours is in terms of h's and m's, so we no longer want this m. Okay, so this is leading us into it. We're going to have to do a substitution. So effectively, what we're saying is if these two things are equal, what we can do is we can make a little substitution for that into here. And so what I'll do is I'll write that out again. So it's going to be R equals 2h minus 1 multiplied by S over h, take away the h. And all I've done is I've changed that little blue bit that I've underlined, that M, for an S over h. And we don't need to simplify. That's it. Let's leave it like that. Not create any work for ourselves. So 2h minus 1 S over h, take away h. Okay. Oh, we've not got far to go. Final question. A molecule has a height h and a width w. For example, molecule 4 in question 3 has h equals 3 and w equals 4. Use your answer in question 4, part D, to show that R equals 2hw minus h minus w. Now, when I was doing this investigation first time, this one just made me think a little bit. And I was unsure about how to progress on this. So, if I'm being honest with you, what I did in this situation was I tried to move on. And I tried to just see if it was possible for me to go on to part B, because I was unsure. So, let's have a look here. So we've got the square molecule, and this is how I did it. So for a square molecule, the thing that I was thinking actually is that the height h will equal the width w. Okay, so I'm going to be using this information that we needed to show in the previous question, and it took me a little while, which is fine. And this is something that you can do. So if h is equal to w, I can choose one of them, and I just chose to make them all w's. R, again, I'm just copying out this formula, equals 2 times w, or w squared. Take away, instead of an h, it's the same as a w, take away another w. Can it have 544 rods? Now 544 is R, so 544 will have to equal 2w squared minus a w, sorry, hang on, we've got minus 2 w's, haven't we? Take away 2 w's if I simplify. Now we've got a quadratic to solve. We haven't done much on quadratics yet, but let's just talk you through it, what we're going to be looking for to do anyway. Here, all of these are multiples of 2, so I can divide everything by 2. That makes my life a little bit easier. 544 divided by 2 is 272. W squared minus w. Put everything across to one side. Factorize, or you can get your GDC to do this for you. And this should be w plus 16. Oh, I've not got a pen. W plus 16 and w minus 17. So if we think about what the solution to these are, it's going to be w will either equal minus 16 or w equals 17. Only one of those is a sensible answer, so that's when the width and height are both 17 because it's a square, and so the answer is yes. If you just put an answer of yes, unfortunately that's not going to be worth many marks at all. In fact, you only get the mark if you put the h value of 17. The other method is for solving that quadratic, the 544, at this point here. So 2 marks for that question there. And the process that I went through was then I went back to this previous question and looking at this, height h of 3, width of 4. Well, what we're dealing with is height and width, and that gives us the number of spheres in our molecule system that we're building up. So the number of spheres should equal the height times the width. Surely it's just a rectangle, and it's that idea that will open up the rest of this question. So we know from our previous answer that's being referred to. So it asks us to refer to this answer, part 4D. So let's just copy it out. What did I get? 2h minus 1 equals S over h. Okay, I'll just copy that here. So that was R is equal to 2h minus 1 lots of S over h, take away an h. But we identified that there's no s's in it, the formula that we're aiming for. And I need to probably emphasize this point. As soon as you get a show that question, it means you can't use this information. You've basically got to arrive at it somehow. So we're going to try and piece things together. So I'm using this first of all, and then what I'm going to do is I'm going to use this idea and substitute in. So if S has a value of HW here, then S is going to change for HW here. That's not very bright highlighter, is it? HW here and S here. So let's do that. So R will equal 2h minus 1 HW over H minus an H, which is quite nice because if I multiply and divide by an H, nothing happens, so I can cancel those out. What I'm left with, therefore, is if I expand my bracket now, R equals 2HW minus a W minus another H, which is exactly what we had here on the show that. So we can say, yeah, that's our answer. Yep. And that part was also worth 2 marks. So it was 2 marks for this one and 2 marks for this one. And that's us finished.